All right. So we left off kind of thinking about doing some review. This is some basic supply and demand. We'll probably touch on equilibrium today. So we had kind of different things that would shift demand, just kind of a reminder there. I think the way I always want to think about shifts in supply or demand is, let's say we've got quantity, price. So here's my original demand curve, right? If I see an increase in demand, really what that's saying is even if I was to keep the price the same, I'm going to be able to sell more of this product. So you can think about at any given price, whatever we were selling before, we can call this demand curve 1, right? That increase in demand means that at that same price, I'm now able to sell a higher number of units. And that's going to be the case no matter what price I look at. So I could think about up here, if I was up at here at this price, I can now sell a higher quantity of that product. So if we looked at every single price, that would kind of build out what our new demand curve would be, right? So that's the way that I kind of think about demand shifts. So if you're seeing a demand increase, right, you could think about, okay, does that go to the left or the right? Well, I said last class, an easy way to remember that increases, you're kind of going away from that 0 point. But also you can think about it this way too, that at any given price, we now see that there's a higher quantity being sold, and then vice versa for demand decreases, okay? Any questions on that? If it's ever too small or anything, let me know if you can't see something. Okay. So just kind of reviewing then some supply shifters as well. It kind of works a little bit different. I think visually, for some reason, supply shifts like don't always kind of work with our brain, but we can think about a supply decrease would mean that at any given price, I'm going to see less of the product being sold. So my supply decrease is kind of this shift to the left, right? Where you almost think about it, it's like moving closer to the y-axis, right? And then we have a supply increase. It's going to be that at every given price, we now sell more of the product, right? So that supply increase, once again, it's moving away. Whoops. Why is this? Oh, like this. So it's moving away from that 0 point, right? It's kind of moving further from that origin, right? So we've got supply increases, supply decreases. What are some things that are going to cause these, right? Because remember, the supply curve is going to tell us the relationship that exists between the price and the quantity supplied, right? It's the relationship between those two things. Anything else that changes other than the price of the good is going to shift that supply curve. I shouldn't say anything that changes, but anything that's related to how much someone's going to purchase, or sorry, how much someone's going to supply would shift that supply curve. So one of the main things we can think about are input prices, right? Remember I said last class, our demand curve reflects like the marginal benefit of each unit, and our supply curve reflects the marginal cost of each unit. So if input prices goes up, what happens to our marginal costs? They go up, right? It's going to cost us more to supply that, whatever quantity of that good it is, to the market, okay? So we're going to see an increase in our marginal costs, which, I want to think about it this way. So we've got our supply curve, quantity, price here, oops, ignore that, right? We've got our original supply curve, which we can kind of think about as reflecting our marginal costs. So if our input prices go up, no matter what quantity we're looking at, our marginal costs are now higher. I'm looking out at a quantity out here, our marginal costs are now higher, right? So if I did that at every single possible quantity, you can kind of see our new supply curve would be up here visually, but really what this is saying is we're seeing a decrease in supply, right? At any given price, there's now less quantity supply. Right? So increases in input prices is going to decrease that supply curve. And kind of intuitively, that makes sense, right? If it costs me more to make something, I'm less likely to produce it and sell it to the market because there's less of a possibility that I can make money selling it, right? Because people haven't changed how much they value this good. It's just that now it costs me a lot more money to produce it, right? So that's kind of the idea of how input prices are going to shift or kind of decrease our supply curve. And I kind of have a summary, like you go in either way, right? Input prices could go up or could go down. Another kind of major one we always talk about, and it's really just the same thing as input prices, is if we see technology improvements. So technology improvements basically make all of our workers or our machinery more efficient, right? If our workers are more efficient, I can get a higher number of units by paying the same number of workers. So essentially, each unit would kind of cost me less. So technology improvements are really decreasing my input prices, right? Or it could even be something like technology, I don't know, I'm producing baseball bats or something, and I get some technology improvements, so I have less waste, right, in my production process, and therefore can produce a higher number, right, while still paying for the same, machinery or the same amount for the machinery I had before. You can think about, I kind of already explained that, but like the technology improvement could also just decrease the number of required inputs that I have. So maybe I could actually completely cut out labor, right, and only have to rely on machinery, kind of lower my costs that way. These are kind of two different examples, and I'll maybe introduce the idea of the labor market here today. So the first one, I kind of mentioned this baseball bat example already. But you could also think about, well, what happens when I see increases in my labor costs, right? So think about like a league minimum, right? So a lot of different sports leagues, right? The union has kind of went to bat for some of the lower quality players and said, look, we realize like the bench players aren't really contributing a whole lot to our team's success necessarily on paper, but right, we want to ensure that anyone working this league earns a certain amount, right? So they set these league minimums that you can't sign a player for less than this, right? What's that going to do to the overall kind of labor cost to these teams? Yeah, so all these players before, I was paying them, I don't know, $50,000, $100,000 contracts. Well, now if the league minimum is $1 million, well, now to fill out my roster, I'm going to have to increase my cost. And that's assuming we hold constant every other player's salary that's above that minimum, right? So we could also kind of, in the context of what we're going to be doing, a lot of times these league minimums, and then eventually we'll get to the issues that exist with league maximums, that could influence kind of our supply curve there, right? So if you think about it this way, so if I want to think about the product market as just being the number of games played in a specific league, if I start to increase the league minimum to something ridiculous, like $20 million, there may be a lot fewer teams who find it profitable to even exist in the league, right? You could theoretically drive them out if you made it so expensive to kind of fill out the roster, right? Or have enough players to just play the game, right? Now, we never see that in practice because the league doesn't want to force teams out, and it doesn't want to have kind of a less quality product. But in theory, that would be the idea, right? And that's a kind of a major input price we can think of. Another thing related to these input prices are taxes. So we'll do a little bit with some. We'll have a lot of different examples with taxes. Here, I kind of kept this as more general, and you can kind of think about. You probably could see this in like a 201 or a 301 example, where we're just thinking about a general product like alcoholic drinks sold at the stadium. So if we taxed alcoholic drinks that are sold in large venues, essentially all we're doing is increasing the input prices, right? Now to sell that same, can of beer or whatever, if they pour it from the tap, it's going to be whatever the cost was before plus this additional tax, right? So works just the same as increasing input prices. It's going to decrease our supply curve. Okay. We start to actually work with some more formulas in this class for our supply and demand functions and actually like solving for equilibriums and things. The difference between our old supply curve and the new supply curve with the tax is just the difference in the tax, right? So if I look at any quantity, say quantity of 10 here, the difference between these two, the supply curve and the supply curve with the tax, is just the value of the tax, right? It's the marginal cost of whatever existed before plus the additional cost now of the tax, right? So usually when we talk about supply shifts, we don't know how much they're shifting. But with a tax, we know it's shifting exactly whatever the value of that tax is, okay? Any questions up to this point? Like I said, I'm just kind of trying to go quickly a little bit through this review to kind of give us a nice base, but if there's any questions, I want to make sure we have a good kind of refresher of the fundamentals here. Okay. So some other things, kind of like with the number of consumers, that increases, we see an increase in demand. If the number of sellers increases, we'll also see an increase in supply, right? So kind of an example would be, let's say that there was some equilibrium price for a particular league's games, right? Didn't matter what team it was. This is kind of maybe a little bit step away from reality, but just go with me for a second. So every team has the exact same demand curve, exact same market size. So they're all kind of charged in this competitive market. They have to take the prices given, right, for whatever the ticket price is. If I keep that ticket price the same, but I see 30 instead of 20 teams, well, they all had the same cost structure, right? They would all be willing to supply the same number of tickets. That same number of tickets times 20 is going to be less than that same number of tickets times 30. Right? I've just added more teams that are going to be selling at that given price. Right? So an increase in the number of sellers, increase in the number of teams, mostly in the context of what we're going to be looking at, we should see an increase in the supply curve. It's very seldom, although we could probably go back far enough, has been a couple occasions where we see leagues kind of get smaller and work in the exact opposite way. Right? So that's kind of, instead of tickets, we could also think about this as the number of games. Right. And this one's like almost just a byproduct of math, right? If I have 20 teams, right, and I'm playing in the NFL a 16-game season, well, if I add an additional 10 teams and they all still play 16 games, I've just added a higher quantity supply, right? I'm supplying what? 16 times 10, 160 more games from that additional increase in the number of sellers, right? So it doesn't just have to be the ticket market. We could think about product markets also as just like the number of games played in the league. Okay. And we can think about this as well. When different leagues make contracts, maybe this is the number of games even played, but the number of games that are sold to be on TV. Okay. So we'll start thinking about product markets that are going to be the definition of what product we're looking at is going to become important, right? Because the number of games played is different than, right, which I'm selling tickets to, or is different than the number of games maybe sold to the TV rights to. Okay? So we'll have to be pretty intentional about how we specify the products that we're looking at. Some other supply shifters, we can think about this. They could, some of these would exist as demand shifters as well. Although for the context of this class, we'll probably mainly focus on the supply shift aspect of them, but would be expectations. So market expectations would be something like, more general ideas. But I think it's going to be a really cold winter, and I think that natural gas is going to, used to heat homes. Potentially that higher or that colder expected winter is going to lead to companies wanting to wait and sell more of their product in the winter as opposed to now, right? Because I know that now that the demand is low, people will be willing to pay less, but in the future, if I expect something to change, with the weather, colder months, I'm going to want to try to sell more of my product then. Now, this doesn't really apply to anything we're going to do necessarily in this class. So something else might be like the UFC, right? They're thinking about when they're going to plan their events. You'll see a lot of times, they're not going to put it on like a big holiday if they know that, on New Year's Eve, not many people are going to be kind of tuning into the event. They're going to be out and about. They're going to be at parties, things like that. Potentially, the UFC looks at that and says, well, we're not going to put our big event on New Year's Eve weekend. We'll put it the week prior or the week after, right? We want it around this time, but we know that we're going to be competing with a million other products on New Year's Eve. Think about bars and restaurants, things like families even, right? They're going to be competing with a lot of other aspects. And so they might decrease their demand for New Year's Eve they might decrease their supply of this event on New Year's Eve and hold off and supply it on a different weekend, right? So this is kind of the idea of maybe just the, whatever market we're thinking about, there could be expectations of different events that could influence whether or not these leagues, these teams, in this case, the UFC as an organization, supplying their products, supplying this huge event with all these fights. Okay. Price expectations will also be, if I expect the price is going to be higher in the future, as a producer, I'm going to want to hold on to my product and sell it later. Right? So higher expected prices in the future means that currently I'll supply less, hold off and supply it when the price is high. Right? So current supply would go down if we expect prices to be higher in the future, and vice versa. Right? So I've got kind of the vice versa here, right? If we expect lower prices in a month, I'm going to want to sell all of my product now at the higher price. Right? So we'll kind of start to think about expectations in some examples in this course. So I wanted to kind of set those up here now. Once again, just a review of some kind of 201 stuff. So if I'm looking at this, maybe this is a potential question I'd put on like one of those online quizzes. after class, although I won't have one today since we kind of have an extended weekend. We won't meet until, well, I guess for you guys, it's not extended for our class, but extended in the sense of you won't return to classes on Monday. So let's say I'm looking at these different models and I think about what if the price of hops, which is a major input in the production of beer, increases. What's going to happen to the supply curve for stadium beers, right? Yeah. Yeah, right. I see this increase in my input prices, so people are going to supply less, right? I see this decrease or this leftward shift in my supply curve. A would reflect an increase in that supply curve, and what would C kind of depict? Either one of them. Not necessarily an increase in demand here. Now, if you're thinking about these as, so if you're thinking about these as the equilibrium points, they might be a byproduct of an increase in demand. So I'd be with you on that. I think I have the demand symbol down here. I meant to delete that as well as the curve. I was just copy and pasting the thing. So what this would reflect is no changes in the outside factors that influence supply, but simply what would happen to the quantity supplied if I were to change the price, holding all those other factors constant. Right? So remember, the supply curve tells us the relationship between the price that you charge and the quantity that you would kind of supply to the market. So a movement along that supply curve is what happens if I change the price of that good. It's how quantity supply changes if I change the price of beer here, holding all these other factors constant. Price expectations haven't changed, the number of sellers haven't changed, all these other things that can shift supply, we're holding those constant. Now, if I change the price of the good I'm looking at, I'm just moving along that supply curve. Okay. Was someone saying something over here? I didn't mean to cut you off. I was saying it was just a change. Yeah, exactly. Yep. So what if I saw stadium hot dogs and the price of stadium hot dogs increases? Well, I just kind of spoiled this one, right? I'm looking at a change in the price of the good. So I'm simply going to be moving along that supply curve. Okay. So now that we've kind of got some basics of supply and demand, right? How would you say, where's the equilibrium point? Remember this from 201? It is where supply and demand intersect, or the price at which, I think about here, I think a better explanation of equilibrium, although where the two lines intersect is correct, especially visually. Think about it as if I was at this price, this would be the point where quantity supplied, or the point that I'm at in my supply curve, is exactly the same as the quantity demanded. That's why we call it equilibrium, right? The number of products being supplied to the market is exactly enough to, like, I don't say not complete demand, but to like meet demand, right? So where those 2 points intersect, or those two kind of curves intersect, supply and demand are the same, that will be our equilibrium price and our equilibrium quantity. Okay. So kind of a quick overview there. Also, I want to say here, we probably kind of already mentioned all this. Exactly. Yeah, I already said all this. Visually, we can kind of see here's our equilibrium price and quantity. If we were looking at the alcoholic drinks in a stadium, and this is probably something like in millions. I was just kind of using some small numbers just to kind of get a nice visual here. All right, the equilibrium price looks like it's going to be about $9 and 5.5, whatever, thousands or tens of thousands, however we want to, whatever units this was in would be the equilibrium quantity. Okay. Any questions on this before we keep moving? So we'll work later on with actually, what happens if we have some linear equations for both supply and demand. What we'd really be doing there to determine what the actual price and the actual equilibrium quantity would be, we would set those two equations equal to each other, right? Because we know that our equilibrium is the point where the quantity supplied is equal to the quantity demanded. So if we set those two equations equal to each other and solve for the quantity where they're equal to each other, that's going to be the quantity that we see be the equilibrium quantity, right? So we'll put some actual numbers, we'll work through some examples kind of later on with that. But just know that's coming. We will start working a little bit more, probably even more than I do with my 201 course, in terms of using some actual equations to solve for what the equilibrium supply and quantity are. Now, I'm not going to do anything crazy. We'll keep them linear. We're not going to do like any, quadratics or anything like that. So it'll be pretty simplistic, but we will eventually get to that point where we're actually putting a little bit more math into this. But for now, kind of think about the visual, just where those two lines intersect on the graph we're looking at. Okay. So a couple terms that just going to refresh your memory and think about are surplus and shortage. So if instead, let's say the price, oops, if I went too far, the price was set at $12, right? Well, at a price of $12, the quantity demanded, right? The price is now higher than our old equilibrium price. So we should expect the quantity demanded has went down, right? It's no longer 5.5, it's now 4. Right? So our quantity demanded at this higher price is going to be much lower than the amount that producers would be willing to supply, right? With this higher price, right? If I'm selling the product, well, then I'm probably going to sell more than I would before. Right? Excuse me. And why? Well, because every single unit, from 5.5 to 7, at that lower price of $9, well, the marginal cost of all these units was greater than 9. So it would have been costing me more to supply anything past 5.5 to the market than I would be able to sell it for, right? All these marginal cost values would be above that old equilibrium price of 9. However, when I increase that price, well, now I'd be more than willing to supply these because now the price I can sell my product for is greater than the additional cost to produce it. So when we have this higher price, the quantity supplied, producers are going to want to supply more to the market than consumers are going to want to buy. So we have a surplus, right? We've got units sitting out there that no one would purchase. Right? Any questions on that? We could determine the value of the surplus, right, by just taking the difference between my quantity supplied and my quantity demanded. So here, right, we'd have a surplus of 3 units. Okay. Shortage is exactly the opposite. It's when the price is being set lower than that equilibrium price. So if instead of $9, we set the price at 6, well, now at that lower price, the suppliers aren't going to want to sell or aren't going to want to provide as many units to the market. But at that lower price, people be willing to buy more, right? If I go to a game and I've got to spend $9 a beer, like there's probably a limit. I can't, I'm not going to drink 8. It's going to cost me a lot of money, right? But if you lower the price to 6, maybe I'll be willing. Maybe I'd buy up to 8 beers at the stadium while I'm there. So, it's going to work exactly the opposite of a surplus, where we now have quantity demanded being greater than our quantity supplied, right? So we'd say that there's not enough product out there, or we have a shortage. Okay. Questions on this for people? Yeah.
Yeah, I have a question. So can governments put in price floors and price ceilings?
Yeah, so you're jumping the gun, but we've got how far ahead do I go? It's somewhere in the slides here, but we'll eventually get to it. But yeah, so the reason why I'm just reviewing shortages and surplus first is because we do see, and it's not so much in a lot of the content examples we're going to be talking about. It's not so much that the government gets involved in our markets when it comes to the number of games being played or even the labor markets within each league. The government is now essentially going to become like those running the league, right? They're going to institute certain restrictions, or maybe the union kind of proposes certain things that act just like price ceilings and price floors. But it's less likely it's going to be coming from the government now. More likely it's going to be coming from some large organization like the NCAA, right? It might put down some restrictions that have influence on the market for college football. So yeah. Okay. Yep. So when you think about also, we're going to have changes in the equilibrium, right? So these shifts in supply and demand, like kind of thought about earlier, right, are going to shift that equilibrium price and quantity. Okay. So what's going to happen if we're looking at like some apparel market? So I think I did NFL jerseys here. If we see the average income in the US fall, so we'll assume that jerseys are normal goods, right? So this decrease in overall income in the US is going to do what to the jersey market? So if we shift the demand curve to the right, that's actually going to be an increase in demand, right? So if we see lower income, that means that if it's a normal good, people are going to want to buy less of it. So we see this decrease or the leftward shift in demand. So this shift in demand is then going to lead to a new equilibrium price and quantity, right? So I think, kind of give you a nice little visual here. So we already had something drawn, so that's helpful, right? So if we see this decrease in demand, where's our new equilibrium price and quantity going to be? So the points we identified before is the equilibrium. We'll call kind of the first price and the first quantity. So we see this leftward shift, or this decrease in our demand curve, right? Our new equilibrium is where that demand curve hits our supply curve. So that demand decrease would cause the equilibrium quantity to fall, and also the equilibrium price to fall, right? So I'm not going to go through an example of every type of shift we could see, right? But you could think about, you should be able to draw a shift, right? And identify what direction the equilibrium price and quantity have moved, okay? So this is a little bit easy when we have one shift, right? So I think the next example I have, and let me leave this up here on the screen. So if you are kind of taking notes, it'll still be down here. I think the next one I have is, what if we saw some technology improvement so that, you know, they can produce the same number of jerseys at a lower cost, right? Or essentially some technology improvement that has decreased our input costs, right? Or input prices. So what's that going to do in the market for jerseys? It's going to shift supply. If input prices are lower, I'm going to actually see a supply increase, right? So if I'm thinking about what that's going to look like, I wish I had my probably somewhere like that. So let me see if I can imagine that's not there for right now, right? We're back to where we only had kind of our original supply and demand. Now we see this shift in supply. So we said it was an increase or a shift to the right. I guess I have to move my marker to draw it, right? Now where's my new equilibrium point? It's going to be right here, right? So I could think about just the supply increase, right? I'm kind of running a room here, right? But that would lower, right, the price. It's going from P1 to P3, but that supply increase would increase my quantity. So I kind of notice here, I try to use a lot of different colors here. If you're taking notes, I would suggest maybe having like a couple different colored pens would sometimes be pretty useful. Now, I drew these on the same graph, so it's a little bit difficult to see, but right, if we were just to look at the effect of that supply increase, it drove quantity up, but price down. Okay. Now, if we have these shifts going on simultaneously, it depends on how I draw them. I tried to draw this pretty close, but notice what's actually, if I saw both of these things happen at the same time, where would my new equilibrium point be? Where my new supply, my new demand curve intersect? So I try to draw this such that you can see if they were equal shifts, well, remember the supply increase was causing quantity to go up, the demand decrease was causing quantity to go down. If they were the equally sized shift, what's going to happen to the equilibrium quantity? It's actually going to stay exactly the same. So it kind of depends on how I draw this. If I draw one as a much larger shift than the other, well, then whichever one I drew larger, that's going to be the one that kind of dominates, right? So the way I always try to think about simultaneous shifts is write down what each shift would do, because sometimes we have an indeterminate kind of answer, right? Depends on the size of the relative size of the shifts about whether or not quantity is going to go up, down, or even stay the same. Okay? So I would start out doing something like this, right? We originally did that demand decrease. So the effect of the demand decrease was that we saw equilibrium prices go down, and we also saw equilibrium quantities fall. If we then think about what was the effect of the supply increase, our other simultaneous shift, well, there we saw that it pushed prices down as well, but that it drove quantities up. So now that I have each one of these effects, kind of what their impacts will be written down individually, if I see both of them happen at the same time, well, they both drive price down, so I know that price will fall, but they push quantity in different directions. So usually I'll write this as something like this, right? Or the terminology we'll use is the change is indeterminate, right? We can't say whether or not quantity goes up or down without additional information. Now, if you told me that, you know, whatever caused the supply curve to increase was a larger shift than the demand decrease, well, then I can start to make statements, right? But without any other additional information, I would say they're both pushing quantity in different directions. The effect is indeterminate. Okay. Any questions up to this point? I know I got a lot going on in one graph here, so. Okay. All right, so, and that's all this was. It was kind of combining the two. This slide was combining the two. We kind of already worked through that. Right? So I put up these two slides, which are just like a summary of different combinations of supply and demand increases and decreases. So it's kind of a nice summary slide to go back on as kind of a reference if you're having some issues with a particular example, because I'm not going to work through all the different combinations, right, in class, but they would all work similar, right? As long as you kind of write down the effect of each individual change, you can then determine what the total effect is of those two simultaneous changes. Okay. Questions on this? All right. So get this out of the way. I also have another summary slide. Like if you want to write this out, like the shorthand effect of everything, this would be one way you do it. I'll typically, I do use the shorthand a lot where I use, increases, decreases, and then kind of our indeterminate. Right? So here's kind of another like sample question that maybe I would put on one of these online quizzes. But what would the effect be in the market for NBA jerseys if the income across the country increases? So now we have income increasing. Think about jerseys being a normal good, right? Then an increase in income should shift which curve? Demand, and it should increase it or shift it to the right. Okay. So here we're looking for an increase in demand or a shift to the right. So it looks like it should be A there. Okay. I could then do, what if there's two new expansion teams? Right? What curve is this going to shift? Supply, right? Increase, so it's going to be a shift to the right. Okay. Oops. And then if we had the combination of the two, so we would have a demand, it was a demand increase and a supply increase. So supply increase and demand increase would be up here. Now, one thing I'll point out here, and here we think of these two new teams as being an increase in the number of sellers. Right? So we have a higher number of sellers, so we saw the supply increase. Why could you potentially argue that this is going to influence the demand curve? Yeah. Yeah, actually, would almost one way I could like shut that down almost is to say, what if the two new teams, right, joined existing cities? So maybe now instead of having one team in New York and Chicago, maybe I have two in each. Well, that wouldn't really influence my consumer base much or kind of the increased number of consumers. But if I'm in completely new cities, I might be able to like attract a lot more people to being a fan or to, to kind of being more invested and kind of increase the overall demand for my product as well, because I now have a higher number of consumers. Yep. So, you'll think about if I'm a league and I'm thinking about new expansion teams, I probably want to try to go to an area that is, I feel, doesn't have a close substitute, right? There isn't already a team that's near that existing area. So I'm getting ahead of myself here, but I want us to think through these issues. So if I'm also a team expanding, and we'll dive more into this later on in the course, but why might, instead of trying to find one of these new cities, like a new market, why might I want to try to put a second team in one of the really large markets? Yeah.
They already have an arena.
They already have an arena. So for one, I mean, for the teams themselves, they would definitely like that if they could somehow share a space, right? They can cut costs in half essentially. But what's another reason for the league why they might want to do that? If I think about the market of Indianapolis, let's say it doesn't have what doesn't it have? A baseball team, right? But I also then look at what's a city that doesn't have two baseball teams. Maybe I look at Houston. Houston is huge. So maybe instead of a new team in Indianapolis, there's enough existing demand where two teams in Houston, right, would actually increase league profits more than putting that team over in Indianapolis or something like that. right? So it's not just about a new market, it's really also the size, right? I want to start thinking about the relative size of these markets as well. So I briefly kind of touched on this at the end of last class, but the ticket market is a little bit unique, right? So we said that the supply curve in a ticket market doesn't kind of follow our traditional thinking of being this increasing marginal cost, because the stadium's already built, the seats are there, you know, whether or not we choose to sell 100 or 1,000 tickets, it's the same marginal cost of providing each of those additional tickets, right? Excuse me. So it's usually, we kind of want to think about it's completely vertical. And I said it's vertical in the sense that it actually runs along the x-axis. The marginal cost is actually zero. And then we're limited, like we can only sell the number of tickets, whatever stadium capacity is. Okay. There are some exceptions I would mention, and they are probably, I would argue, probably a little bit too, I don't know, difficult for this, maybe not too difficult for this class, but we could also see something weird. Like I know there's like minor league baseball stadiums and other stadiums where they'll like, I don't say rope off, but they'll like put, you know, things that close off different sections of the stadium so that potentially I could like kind of in bulk numbers of seats actually change where that capacity would be. And maybe because I can shut down, like, let's say the upper deck, I can now reduce my labor costs of the number of workers that I need at the game, maybe some, you know, minor electricity costs or things, security costs. So I can kind of cut down the number of people I need in the stadium. So potentially we actually would have some changes in marginal costs there. And you kind of have like this like step function of a supply curve. We won't go to that. We'll kind of think about just the stadium capacity being what our supply curve is. Some other exceptions would be really choosing, you know, where it wouldn't be that we have a vertical supply curve, would be something that it doesn't have its stadium. They're just choosing locations. So like, I'll try to bring them into a couple of these examples because they are a little bit more interesting, even than like our main 4 leagues, which is like the UFC, because they are getting rather large. But when they're choosing venues, they can kind of choose their stadium capacity, right? So it's a little bit different there, and maybe larger stadiums, right? It's going to cost them a little bit more. So they probably are facing more of like this increasing marginal cost curve. Okay. So if we want to think about like within the same season, you know, we're not comparing across years or across teams, but for a specific team in the same season, we can think about what's going to drive difference in ticket prices are really only things that are going to influence the demand curve. We've kind of shut down the supply curve. The stadium capacity is what it is in this current year. Now, long run, maybe then we have a little bit more, you know, options of choosing stadium capacity. And so then we kind of think about the long run cost curve probably does kind of look like it's increasing. But in the short run, our cost curve is completely vertical. Right? So what do I have here? Some demand shifter examples. I'll draw it out first, and then we'll kind of talk about more specifically some things that would cause changes in the ticket market. So we'll keep it pretty basic here to begin with. But I said my supply curve essentially runs along that x-axis and then is vertical at whatever my stadium's capacity is. I then think about, I've got some demand curve, right? And let's say this was my demand curve. Okay. The equilibrium price for a ticket for this team and whatever league we're looking at would be where demand hits supply, right? Or where you know, they would be the price at which they would be the exact same. So we kind of could think about, here's my equilibrium price if demand was this high. If demand continues to increase, what's going to happen to the equilibrium quantity sold? Yeah, you know, trick question, right? It's not going to change at all, right? Because if I see a demand increase here, it's still going to intersect on the vertical axis. So my equilibrium quantity would remain the same. It's just going to be that the ticket prices are going to be higher. So when we're looking at data, we start to kind of think about trying to estimate different things with linear regression. We're going to have to be careful when it comes to tickets, because you could look at the number of tickets sold. For example, there was a time, even when they were bad, I think the Chicago Cubs, I forget how many games they had like sold out. I mean, the percent of games that they sold out was very high. So if you look at just the number of tickets sold, you're gonna be like, there was no change, right? There's no change in demand like there was. Well, no, they were already hitting stadium capacity. Probably a better reflection of whether or not demand was increasing and decreasing over that time was what was the average ticket price, right? Because they can sell, they could sell if all they want to do is sell that stadium out, right? Or if demand is already high enough to sell that stadium out, the indicator of whether or not demand is continuing to increase would be that people are willing to pay more for the tickets, right? So we would want to look at ticket prices there as opposed to the quantity of tickets sold. What else do I want to say here? Oh, what if, let's say in like more recent years, we've actually seen somewhat of a decline in just the overall demand for baseball, right? For Major League Baseball, right? Not one specific team, but overall as a product, it seems not a wild decline, but a minimal decline. So let's say demand decreased a little bit. And here's now our new demand curve. Well, now where's our equilibrium going to be? It's kind of a weird one, but it intersects my supply curve actually on the x-axis, right? So if it was a truly competitive market, what should the equilibrium price be? It's actually going to be 0. I'm at this point, if demand gets low enough to where I can't hit capacity, if it was a truly perfectly competitive market, I want to set the price at 0 just to fill out as much of my stadium as I possibly could. Now, this is not a good thing for the team, right? Like this is 0 producer surplus. And this isn't actually the real scenario that we typically see, right? So when I think about a perfectly competitive market, it would probably be more like, even if, let me think of an area. So even if I don't have monopoly power within my region. So let's say you think about any city that has 2 teams, right? If I'm living in Chicago, right, and I'm a Chicago Cubs fan, what's probably true about my demand to go to a White Sox game? I can't remember the name of the stadium. It's changed a million times. So what would be true probably about my demand to go to a White Sox game? It's going to be relatively low, right? My demand to buy a ticket to a certain game is going to depend on the team was playing. So even if there's no monopoly power, at the very least, these markets would look more like what? So if there's fan loyalty that's changing there to be differences in demand, right? But there is just a general overall demand from consumers to attend whatever sporting event this is, then it's probably that we have more of a monopolistically competitive market. We've really got the same product. We are playing the same sport, right? We're providing the same product, but because we have brand loyalty, which is like fan allegiance, that we're actually causing there to be some differentiation between our products. And therefore, we both are actually facing slightly different demand curves. Okay? So it's probably going to be that, yeah, we don't have a perfectly competitive market. That's why we don't see ticket prices be 0, right? But right, we probably have something that looks a little more like a monopolistically competitive market, or in some regions, right? Let's say that I'm a family and I'm growing up in, I don't know, let me think of a place where they're not really driving distance anywhere else. Maybe I'm in northern Wisconsin, right? And I want to take, or better yet, the UP, right? Upper Peninsula of Michigan. And I want to take my kid to an NFL game. Well, it's a young kid. I don't want to travel across the country, right? Whatever. The only game that's drivable distance to me would be to go to Green Bay. And so there, right, they essentially have a monopoly for NFL football games, right? So a lot of the times, we'll see either monopoly power or monopolistically competitive markets when it comes to the market for NFL games being played. And so we won't actually see prices be 0. But if it was a perfectly competitive market, potentially we could see that. Right? If you're competing, I'm trying to think of another good example of maybe something we see where prices are almost 0. So it's not a great example, but a lot of high school sports, sometimes there's literally no admission to come, right? Demand for some of these smaller sports is so low that they literally there isn't a ticket or a price for tickets, right? I can think about, I used to do cross country in high school, which, yeah, I have no idea why I did that. but you know, you could just walk up and watch because demand's so low, right? And really there, you just had so many other substitutes for what you could do with your time. They knew they had no power to be able to charge any other price other than 0. All right. So any questions on that before I keep going? All right. So we'll think about some things that might shift demand a little bit more sport specific. I'll use Purdue basketball tickets here because I'm a Purdue fan and they actually have a decent team this year. So what if we think about the team is winning, right? So we've got a high quality team, right? What's probably going to happen to demand there? We're going to see an increase in demand, right? When a team is of lower quality, they're not having as good of a year, we'll probably see a decrease in demand. So that's not really, doesn't really fit any of our other categories for demand shifters, but it's going to play a huge role when it comes to looking at the market for games or for tickets for different sporting events. Another interesting thing to start to think about is opponent quality, right? So we'll get a little bit more into this. I don't think I have one set out here. Yeah, I don't. So opponent quality, you can think about even if a team isn't doing well, their rivalry games typically always tend to sell a higher number of tickets or sell at higher prices, right? I mean, you know, if you don't believe me, I know that there's some databases on old ticket prices. If you look at years when both the White Sox and the Cubs are bad, their ticket prices would be very low. And then when they play each other in Chicago, substantially higher, right? So there's some things like that play a role.
Oh, like special events like student night or homecoming games.
Yeah, I'm sure at the collegiate level, especially, I would probably guess more for football than basketball. That definitely shifts the demand curve, but there's a lot of other things that wouldn't really apply in any other product market that we'll see pop up when we're looking at like the market for games or the ticket market here. Yeah. Now, another thing with opponent quality that we'll dive much more in depth into later on the semester is, how do you think about it this way? Opponent quality doesn't necessarily have to be just a rivalry game, right? What do you think would probably be true about the number of tickets sold to an Alabama A&M football game as opposed to the Alabama Auburn game? Much higher ticket, right? Because the opponent quality is higher, but not just that the opponent quality is higher, but it's that the other game, you already know the outcome, right? People don't like to go to watch things if they already know the outcome, right? So there's something called competitive balance, which is, you know, the odds of either team winning. Perfectly competitive balance would be it's like a 50-50 odds of either team winning, right? As that gets more and more out of whack, let's say one of the teams has a 90% chance of winning, the demand we see for those games is significantly lower than those more even matched games, right? So the opponent quality kind of plays a role primarily not through rivalries, things like that, but through this competitive balance measure. Okay? Timing of sporting events will start to play a role. Right, we've got very different ticket prices we see across different days. Time of the day will kind of influence it. I always give the example of, you know, college basketball games. If we're thinking about Purdue basketball tickets, if you want to buy a ticket for any game from like December 10th to January 10th, they're very cheap, right? Because none of the students or whatever your winter break weeks would be, there's nobody around, so they have significantly less demand, and so you see ticket prices tend to be quite a bit lower over that time period as well. So timing is going to really play a role here, right? And then whether or not the game is televised, right? So a lot of times when we see a game be televised, you actually might see that there's a lower number of tickets sold to the event itself, right? Because if I want to watch the game and it's not on television, I would have to attend the game. That's the only way I'm going to be able to watch it. Now, if it's on TV, I have the option to substitute away from purchasing a ticket to the game and start to purchase more. When you think about purchase more, I'll just, you know, kind of bundled into what I'm paying for cable or just watching it on whatever, you know, streaming app that I've got, right? But I've purchased those streaming apps as opposed to purchasing a ticket. So we can kind of think about televised games and in-person games are actually two different products and they're actually substitute goods, which is why, and maybe in this market, they do pretty well. So I don't know if it happens a lot here. I haven't noticed as much. But what do television networks sometimes do to games if you're close enough to them and they don't sell enough tickets? Yeah, they black them out, right? So I'm a Detroit Lions fan and I grew up in Michigan. And they were almost always blacked out, right? Like, because what the agreement that the league has made is that if we don't sell a certain number of tickets to a particular event, well, we're generating revenue for that. We want people to be there. And yeah, we'll generate revenue when their game is on television with you, but not near as much as we can get them into the stadium and actually, purchasing additional items. And so when they make these agreements to have different number of NFL games on whatever network we're thinking about, it's, if it's a local team, right, that the league expects it's a high possibility people could drive and watch the game in person, then the league says, well, if we don't sell enough tickets to the stadium for in-person events, we're not going to put it on TV. That way, we're almost like forcing people, if they want to consume this product, they don't have this substitute anymore, right? So it's kind of an interesting thing that kind of comes out of it, and it really is because those two things are substitute goods. Right? So here I've got an example of maybe a price ceiling. So it's kind of interesting in the ticket market. I think I'll go through this and draw it out. And what example we have a price ceiling in the ticket market? I'll try to give you a good one here in just a second. So let's say we've got demand curve. We've got our stadium capacity or our supply curve here. And if I were to just set ticket prices, they'd be way up here, right? And maybe if it's a college basketball team, I look at this and say, well, man, I don't know. I forget what the number was there. I think it was like $100 or something. Like maybe this is a really good team. They're having a really good year. They're in a big conference. They're able to charge a lot for their tickets, right? But the university goes, well, look, this is an athletic program at our university. Seems pretty wild that our own students couldn't attend it, right? So what do? Is they start to set different prices, or what we would call price discrimination, and say that we want our students to be able to attend this event, so we're going to offer the games to them at a lower cost, right? What that's essentially saying is, yeah, when we're thinking about the demand that's coming from students, right, it probably isn't going to be high enough. They don't have the ability to pay these higher prices. So we might institute something like a price ceiling, right? Where you say, well, you can't charge, I think it was $15 that I had, so this is my price ceiling. You can't charge students a price higher than $15 per game. Now, I think that's probably much lower than what the universities actually choose, but you get the idea, right? We're setting a lower price. And so you can think about for student tickets, we can probably sell out kind of the entire, like every student would pay $15 to attend the game. But we also don't just want all students. So what a lot of these universities will do is they set aside sections for student seating, and then the rest of the stadium is kind of more general, right? So that they can still get away and make high revenues off of non-students, but they can fill out the student sections pretty easily. And so if I really wanted to be real precise with this graph in terms of the example I'm giving you, you would actually kind of have like two different markets, right? One where the stadium capacity was however many seats were in the student section, and another that had the stadium capacity be whatever is left, right? But the same principles would apply. So we can kind of draw them in the same one here to make sense of it. So notice now I can have a price ceiling, right? Unlike in a general product market, what's happened to the equilibrium quantity here? So before, my equilibrium was here after the price ceiling. So the quantity hasn't changed at all, right? Now, one thing that's kind of interesting about this as well, and this will be a good time to kind of review some of this before we get into examples where I need to work through a little more quickly. Does anyone remember? So what defines producer surplus? Yeah.
Anything below the supply curve and above the equilibrium.
Yeah, so if I'm thinking here, my supply curve runs along this x-axis, right? So after this price ceiling, my producer surplus was definitely going to be significantly lower. So the athletic department probably hates like student tickets, right? Student ticket sales, right? However, what's happened to consumer surplus? Consumer surplus is the area below my demand curve, but above the price that consumers are going to pay. Well, now with this price ceiling, consumer surplus is everything that's left over. So we've increased consumer surplus dramatically from when the price was 100, and producer surplus is now quite a bit lower. Right? But, you know, maybe there's some externalities here, like we think about having a student section attend the game. Maybe it increases the demand for people even just apply to that university. And so that's why we see universities might want to do something like this, right? Increasing the consumer surplus of your students is probably good for attracting students in the future, right? There's some additional benefits outside this ticket market that this regulation or rule could have. Okay. Yeah. Yeah, so this is going to be a weird scenario. So what's some other product examples we give with this? When we have supply be completely inelastic. So notice here, and just to review, we're not going to like calculate elasticities, but the word elasticity, the definition means how responsive is either consumers or producers to a certain change. Well, here, the elasticity of supply, right? How much is going to be supplied to the market doesn't change at all, even from a relatively large price change, right? So we would say that people were not responsive at all to this price change. Supply is pretty inelastic here. And not only is it pretty inelastic, the way that we have it drawn, it is perfectly inelastic. So if producers aren't responsive at all to price changes, then they're going to bear the entire burden of all the surplus loss. And we actually can end up with zero deadweight loss. It's just a transfer of surplus, right? Before, without the price ceiling, all of this area here would have been producer surplus. After the price ceiling, we've just kind of transferred it. And we end up with zero deadweight loss. So kind of a unique example, but yes, and this would be a case where we don't have any deadweight loss. Any other questions before we keep moving here? All right, so where are we at in time? Okay, we're gonna cover it. You know, so with these lower prices, we can still ensure that all the tickets are purchased. We can end up with no deadweight loss. But the problem is the allocation of these tickets may not be to who values them the most, right? We can guarantee that we can sell out the games, but unless we have some sort of process through which tickets can be resold, it could be that, you know, someone who would have paid a higher amount for that ticket ended up not getting it because there was so many people who would be willing to pay this much lower price ceiling price, right? So, you know, it doesn't look like we've had any kind of surplus loss, but if for whatever reason it's not a fair system in which the order in which people can purchase these tickets, we may end up with people who would have paid more not ending up with the tickets just because of you know, whatever the process is. Right? Yeah.
So in that example, it wouldn't be like a perfect competitive market.
Yeah, right. There would have to be some, it's kind of weird. And I don't know if you've talked about in any of the other courses. So we talk about like with monopolies that there's barriers to entry. We always think about barriers to entry be for producers, but you can actually still have barriers to entry for consumers as well. It's just not as often, right? So let's say, you know, one of the barriers to entry here could be that if there's only a limited time slot, if certain individuals have prior commitments and they can't show up, even if they would have paid twice as much for the ticket, right? There's a barrier to them entering that market to be a consumer if you're only selling it like within a certain time. And I know that because that's what some of these universities will do. They'll open up their student ticket sales within a certain time frame. And this is, you know, usually there's enough demand to where they're sold out very quickly. And if you happen to not be able to make it during that time, as a consumer, you wouldn't be able to participate in that market. However, if we allow for the resale, we can kind of eliminate this issue, right? Because, you know, if we like StubHub or all these, there's like a million of them now where you can go out and buy tickets, people can buy and resell their tickets. Well, there you're guaranteed that whoever values it the most is going to end up being the one who offers to purchase that ticket for the higher price. So when you have the ability of resale, it doesn't matter who purchased the ticket first, right? The person who ends up with a ticket is going to be who's willing to pay the most for it on these other markets after it's originally sold from the university or from the team. Oh, so as I mentioned, so one way to address this as well, because a lot of these students, they might value it very highly. So there may be no prices that they're willing to sell it at. So what they'll do is they cap the number of tickets sold to students. They require student IDs in order for resale to be, you know, to prevent resale on StubHub and things like that. they differentiate the tickets. You have to have a student ID to order to enter the stadium with that specific ticket, right? So there are ways that kind of these teams have dealt with it. What example did I do for price floors here? Yeah, I think we're going to do labor market. I might hold off on this. Let me see if there's a topic I like a little bit better. No, we're going to get a little bit more into the production. So we'll end on this price for them. So we can think about, don't really think, I'm not aware. This might be a good time to say as well. If I at any time say something, but I'm not sure about this, or I don't know the specifics of every single league and every single regulation. So if you're aware of something as a fan of a particular thing, feel free to be like, well, what if they had this? And we'll think on the fly and we'll work through it together. But as far as I know, I can't think of anything that's a price floor in like the ticket market or I think the market for games. I'm not aware of any price floor. Like I don't think there's any rule anywhere that says as a team in this league, you can't sell your tickets for less than this price. Now there might be, and we may not be, I may just not be privy to it, but I've never heard of that being something that any league or any city or something has instituted. So this is a good time then to think about price floors that exist in the labor market, because there is definitely price floors across leagues in the labor market. Right? So when we're thinking about a labor market, it's a little bit different because I think it's not intuitive to our everyday lives, right? So does anyone have labor econ here? Handful, okay, that's good, right? So I've got my quantity of labor here on my x-axis. What's on my y-axis? Yeah, so it's the price of labor, which is, we can think about typically write as wages. Usually I'll just write W there, right? So we're going to think about wages and the quantity of labor, right? Or we can think about, we could call this salary or whatever, however we want to denote it. So let's say we've got some supply curve for labor and some demand curve for labor, right? And we'll go more in depth into this because one issue that we deal with in the labor market for sports that we don't in like almost every other one. Does anyone remember what could be true about the supply curve for labor who had labor economics? Sometimes it's not just increasing like a typical supply curve. We can actually get this, this backward bend, right? And that was primarily to be a little less exact now, but we'll dive deeper into it. It's the idea that if you start to pay someone enough money, they don't want to supply as much of the labor. And we might be measuring labor here as like the number of players, but if we think about an individual supply curve, because each one of these players really, the demand for their labor, it's different, right? They're getting a different player. And so if you pay someone enough, I always use Conor McGregor as the example, and we'll kind of actually work through a model that looks like probably his decision-making process later on. But if you get enough money, right, this income effect dominates to where you're like, yeah, if you're going to pay me a higher amount, I'm actually going to work less because I'm content with the amount of money that I have, right? If I'm content with $100 million, right, and I'm going to say, yeah, at $100 million, I'll fight once a year. Well, what if I paid you $200 million? Well, I was content with 100. I'm still just going to fight one a year, right? And that's not an example of a decrease in the supply, right? So it wouldn't be backward bending, but it would be an example where we don't continue to see this increase in supply for higher wages being paid. And because we're dealing with athletes who make sometimes hundreds of millions of dollars, potentially we start to get to that backward bending part of the supply curve. But for now, let's assume we're not. But I did want to mention that as long as we're talking about it. So we could identify our equilibrium wage and our equilibrium number of players here, or even if it was an individual supply curve, the kind of equilibrium quantity of labor that person would supply. But what happens if the league comes in and says, okay, we're going to set a price floor, which a price floor in the labor market means you can't pay somebody less than this amount. It's like a minimum wage, right? But instead of a minimum wage here, we typically see this kind of be instituted as league minimums, right? We say you can't pay a player less than this if they're going to be in the NBA or the NFL or whatever it is, right? So what that would do is then lead to the equilibrium point being back here, right? So we would have, what do I want to call this? We'll call this Q2. Before, we would have had a higher supply of labor without that league minimum, right? And it kind of makes some sense intuitively because now if the teams have to pay more for their bench players, they're less likely to keep as many bench players. Now there's roster limits and things like that that kind of address this issue. But if we didn't have that, right, and you just had, you know, the league minimum instituted without any additional other regulations, we would see that teams would actually reduce the number of workers that they would employ, I guess, if you want to think about it that way. Okay. Any questions on that? This is kind of a weird question. What happens to the equilibrium wage with a price floor in the labor market? It was down here before. The league minimum literally states I can't pay anybody less than this. So the new equilibrium wage is going to be higher there, right? I can't pay a wage below that league minimum if this rule is binding, right? If there's no way of getting around it, okay? So that's an example of a price floor we might see pop up when we're looking at these different examples. Also in the labor market, what would be an example of a price ceiling we might see? If anyone's aware of them.
Maximum contract.
Yeah, there are values that, and not every league, but there are some leagues that have a value of the maximum amount you can pay a player per year, right? So salary maximums would kind of be like, oh, I didn't draw, it was on the slides, but it would be a price ceiling in the labor market. Right? So we might see examples of that pop up throughout the semester as well. Okay. Yeah, a little less than 10 minutes. Let me go back here. So we'll probably touch on like the production function and kind of think about different market structures like a monopoly versus a perfectly competitive market. And we'll think about how monopoly power will kind of look a little bit different in a ticket market. So this is where we get a more realistic kind of example in the ticket market when we have some monopoly or monopolistic competitive power. So one thing that probably won't do today, but I'll introduce the idea and we'll dive more into it on Tuesday, is I'm going to do some linear regression overview too. So I said, typically on Thursdays, we'll kind of review a paper, but this Thursday, we haven't really been able to go over linear regression review. And I thought it would probably be more efficient to kind of have the first one be next week. So we will kind of take a look at an academic paper. We'll kind of need a little more information about linear regression before we actually tackle what they've done. So we'll be doing a lot of linear regression stuff on Tuesday. Now, kind of the general overview of what we're going to be doing with linear regression, just the overarching idea, is we're trying to determine the relationship that exists between two variables, call them X and Y, right? And we want to know as X changes, as X goes up, what tends to happen to Y, right? So if we increase prices, what tends to happen to the quantity we sell, and right? There's some of these other things as well. And so what we'll do is we'll use some type of data that has a bunch of observations for both this X and this Y variable. So maybe this is something like player age and their salary. So I collect information on every player's age and every salary in the, let's say the NBA, right? I then want to estimate, okay, what's the impact on a player's expected salary if their age goes up or down, right? You're probably thinking about, could be negative, could be positive, right? The players gain skill, but they also, right, physically are deteriorating. So maybe we don't really know what the relationship would for those two variables actually be. So we use this data set, we use something called linear regression, and I'm not going to dive too much into exactly how this works when we have multiple kind of variables in our regression, not in terms of the actual like statistics or mathematics behind it, but focus more on the application of it. We can use Excel to run these regressions or do this regression analysis, and then use these statistics it gives us, which we kind of call slope coefficients, to then start to make predictions about whatever that Y variable is, right? So maybe then once I obtain these coefficients, I can predict the player's age based off of their salary, predict their salary based off of their age. And then I can throw in more variables to this as well. So we'll kind of start out with linear regression on Tuesday, try to get a pretty good review or kind of handle on that, kind of progress the material, and then we'll look at our first paper which I believe the one I'll probably use is stadium beer sales and attendance at the college level. And we'll probably look at that next Thursday. Okay. Any questions from me? All right, I'll also just kind of what you can expect next week. I'll probably after class Tuesday post the first homework assignment. We haven't went through a whole lot, but you can probably at least start to tackle like the first question on it after Tuesday's class as well. Okay. All right. It was fun, safe weekend. I will see you guys on Tuesday.